Hello, my dear students. I'm your maths teacher Priyanka Raut. We had last time started with our first chapter in algebra, that is sets. We are continuing with the topic further in this particular video. So be attentive and just follow the instructions which are given in each of the slide. Okay. Okay, so in our previous session we have learned what is a set, how to write a set, the different ways of writing the set. So we have learned the listing method, set builder method. We have learned different terms involved in a set. Okay, now we are going to learn the different types of sets. Here we have four types, namely the singleton set. Second is the empty set, or also known as the null set. Third one is the finite set, and then we have the infinite set. Let us see each one of them in detail. So first we have the singleton set. Look at the example in the third column. A is equal to 2. So here the element is only 2. So whenever a set has a single element, it is known as the singleton set. Remember, the word single means one. So here when you have only one element in the set, it is forming singleton set. Second one, empty set or null set. The name itself suggests that empty set means there is no element and therefore it is empty, and hence it is under the category of empty set. So if there is not a single element in the set which satisfies the given condition, then it is called a null set or an empty set. You can see the symbol given here. Yes, the symbol is a phi symbol, or you can uh, also write these two brackets with an empty space in between. Okay, so example, they have given b is equal to x such that x is a natural number between 2 and 3. Is there any natural number between 2 and 3? No. Therefore, my answer is an empty set. Okay. Third one, finite set. The word finite itself suggests it is fixed. Correct? So, it has some limited count or number. So, if a set is a null set or number of elements are limited and countable, then it is called a finite set. So, example given here, C is equal to P such that P is a number from 1 to 22 divisible by 4. So, we have answer as C is equal to 4, 8, 12, 16 and 20. So, it is a fixed number of elements, correct? Therefore, it is a finite set. And the last one, infinite set. Again here, the word infinite itself tells us that the set is not in a fixed quantity or a fixed amount, correct, or a fixed number. Therefore here, example given is n, which stands for natural numbers, is 1, 2, 3, comma, dash, 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 because here the natural numbers can go on till infinity. So whenever we have a number of elements in a set which is unlimited and uncountable, then the set is called infinite. So all the four sets are clear with everyone. You have to just try to understand the example given to you, and try to relate it with each type of set and then get your answer. Okay. Let us try out some examples on types of sets. First one, A is X such that X belongs to N and X is an odd number. Now capital N stands for natural numbers, and they have also mentioned that it's an odd number. So which are the odd natural numbers? So my answer is A is equal to 1, 3, 5, 7 and it goes on. So here this is an infinite set because we know that this list is never ending. Next one, B is equal to X such that X belongs to N and 3x minus 1 is equal to 0. Now here they have given us an equation which we need to solve to get the value of x. Now how do we solve it? First they have given us 3x minus 1 equal to 0. I shift 1 on the other side. I'll get 3x is equal to 1. Then further I shift 3 on the other side. I get 1 upon 3. So the value of x is 1 upon 3. Now further they have given that this value belongs to natural number. But we know this is not a natural number, correct? It's a rational number. So here, therefore my set will be a null set. Next one. E is equal to x such that x belongs to I. Capital I stands for integers. And x square is equal to 100. Now here, we know that x square is equal to 100. Correct? So we have to find the value of x. Now which number can give me 100 as a square? 10 and minus 10. Therefore, my answer will be 10 and minus 10. These are the only two integers which can give me my square as 100. Therefore, it's a finite set. So this is how they will be asking you questions. You have to first get your answer in the set builder form and then you are going to solve it. Now let us learn about equal sets. Two sets A and B are said to be equal if every element of set A is in set B and every element of set B is in set A. So here basically the elements are same in both the sets. Okay. So set A and set B are known as equal sets. And symbolically it is written as A equal to B, or even if you write B equal to A, it's one and the same. So let us see few examples. Example 1, A is equal to X such that X is the letter of the word listen. Now here which letters are there in the word listen? Therefore A is equal to L, I, S, T, E, N. Okay. So these are the words these are the letters in the word listen. Now in the second example, Y such that Y is a letter of the word silent. Now if I write this in the listing form, my answer is B is equal to S, comma I, comma L, comma E, N, T. Now compare these elements and the elements in the first example. Yes, they are same. So here, since the elements are same, the two sets are equal sets. Now here the order of the elements doesn't matter. Okay, so I can write it in any order, but here the elements have to be same. So yes, the elements are same, though they are placed in a different format, still the elements are same. Okay, so these are equal sets. So we start with our practice set 1.2. Let us see if you are able to recollect what we have learned earlier. Question 1. Decide which of the following are equal sets and which are not. Justify your answer. So set A, they have given us x such that 3x minus 1 is equal to 2. So I first solve the equation and get the value of x. Now how do we solve it? Look at the solution given below. 3x minus 1 is equal to 2. 3x is equal to 2 plus 1. So when we shift 1 on the other side, it becomes positive. So I get 3x is equal to 3. Therefore, x is equal to 1. So my answer for set A is 1. Next, b is equal to x such that x is a natural number, but x is neither prime nor composite. So again here my set b is equal to 1 because 1 is the only natural number which is neither prime nor composite. Then c is equal to x such that x belongs to n. Now here n is nothing but natural numbers and x is less than 2. So which are the natural numbers less than 2? Only 1. Therefore, again the answer is c is equal to 1. So you can see in all the three sets, the answer is 1. My element is only 1. Therefore, these three are equal sets. Okay. Now question 2 is similar to question 1 which you are going to solve on your own. We move to question 3. One more thing, question 2 you will be doing in your notebooks after question 1. Okay. Question 3. Which of the following are empty sets and why? First one, a is equal to a such that a is a natural number smaller than 0. Now do we have any natural number smaller than 0? No. Therefore my answer is a empty set. Then b, x such that x square is equal to 0. Now square of any number cannot be 0. Therefore again the answer is a empty set. And the last one, c is equal to x such that 5x minus 2 is equal to 0. I simplify this and I get my answer for x is equal to 2 by 5. Now they have given that x belongs to natural number, but here we have got our answer in fraction. So it is not a natural number and therefore my answer is c is equal to an empty set. So yes, all the three questions are empty set and we have justified them by giving our reason. So you will be solving this in your notebooks. Okay. Continue with our practice set 1.2, question 4. Write with reasons which of the following sets are finite or infinite. If you can recollect what we have learned in the earlier slides, finite sets are those which have a fixed or definite number of elements, whereas infinite are those which don't have a fixed number of elements. So here we start with question 1. I have solved first 4 questions for you. The remaining 3 you will solve on your own. Okay, and you'll be writing it in your notebooks. Question 1. A is equal to x such that x is smaller than 10 and x is a natural number. So, my answer is A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So, all the natural numbers less than 10. Therefore, yes, it's a finite set. Next one. B is equal to y such that y is less than minus 1 and y is an integer. So, which are the integers less than 1? Less than minus 1? Yes, these are the negative integers. So it is minus 2, minus 3, minus 4 and it will go on. Therefore, it's a infinite set. Question 3. Set of students of class 9 from your school. Now, since the number of students of class 9 will be fixed, hence it's a finite set. Fourth one, set of people from your village. Now, in the village also we can count the number of people. Yes, and therefore it's a finite set. So you can see here, everywhere I am justifying with reason. So for the next 3 questions also you are going to justify your answer with reason. Okay. So let us learn about Venn diagrams. We had a British logician, John Venn. He was the first one to use closed figure to represent sets. Such representations are called Venn diagrams. Now these Venn diagrams are very useful if you want to solve any word problem based on sets. It makes the sum easier to understand and more simpler instead of just writing steps. How in science diagrams makes understanding better. Similarly here the Venn diagram helps you to understand the different operations with respect to sets easier. So let us understand the use of Venn diagrams from the following examples. We have A is equal to 1, 2, 3, 4, 5. So instead of writing this in bracket, I can also draw a Venn diagram and just write all the elements into it and name the Venn diagram with the name of the set. So I have written here capital A and the elements are inside that oval which is being drawn. Okay. Then B. B is equal to x such that minus 10 is less than or equal to x and x is less than 0 and x is an integer. So they have given us a relation for x. Okay, so x is an integer. Integer includes positive numbers, negative numbers and 0. Now here they have given x is less than or equal to 0. At the same time it is greater than minus 10 or equal to minus 10. So my elements of set B are nothing but the integers between minus 10 and 0. So here in the box given here, the rectangle given here, you can see these are the elements present in my set B. So all the integers from 0 to minus 10. Now why do we include 0 and minus 10? Because here in the question we have less than or equal to sign and greater than and equal to sign. That dash below indicates equal. So it is also less than the number and also equal to that number. Therefore, we are including 0 and minus 10 also in our answer. So this is basically Venn diagram. Let us see further how we apply this in the next operations. Now students, let us learn about subset. Now we have used this word earlier, sub-questions, correct? Sub-question, this word is used when we have questions below one particular question. So we say maybe sub-question number 2 of question 3, correct? Now we use this word because these questions are below or within a particular question, right? Similarly here we have subset. Now subset is if A and B are two given sets and every element of B is also an element of set A, then B is the subset of A, which is symbolically written as B is a subset of A. Can you see that symbol written there? Yes, that is the symbol for subset. It is read as B is a subset of A or B subset A. Okay, now look at the diagram given here, the Venn diagram. They have drawn B inside the set A, means A will include all the elements of B. Correct? So here set A will have some other elements also other than the elements of B, but it will include each and every element of B. Therefore, B is known as the subset of A. So look at the explanation given here. We have A is equal to 1, 2, 3, 4, 5, 6, 7, 8 and B is equal to 2, 4, 6, 8. You can see these elements are present in set A already. Therefore, B is the subset of A. And if I want to show the same thing in Venn diagram form, this is the diagram for it. So subset is clear with everyone? Okay. So we have learned what is a Venn diagram, how to draw it. Then we have learned what is a subset. And we have also seen how to draw a Venn diagram showing subset. Okay. Let us see some more examples of subset. Example 2. N is standing for set of natural numbers and I stands for set of integers. Now think and tell me, all the natural numbers are nothing but positive integers? Yes. So can I write that N is a subset of I? Yes. So this is an example of subset. Example 3. P is equal to X such that X is a square root of 25. What is the square root of 25? 5 and also minus 5. Okay, so my answer for P is P set is equal to 5 and minus 5. Next one, S is equal to Y such that Y belongs to I stands for integers. And Y is greater than or equal to minus 5 and less than or equal to 5. Means all the integers between the range of minus 5 and 5. Therefore, my set S is equal to, look at the set written here, minus 5, comma minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. Now compare this set and my set P. I have the two elements of set P present in set S. Yes, and therefore set P is a subset of set S. Understood now? So whichever set is a subset of the other set, all its elements will be present in the other set. Clear? So now dear students, let us learn what is a universal set. The word universal itself means which includes everyone or everything. So let us begin. Think of a bigger set which will accommodate all the given sets under consideration, which in general is known as a universal set. So it's a bigger set or a bigger group which includes other smaller groups into it or smaller sets into it. Okay. So that the sets under consideration are the subsets of the universal sets. So those smaller groups which are present under the universal set will be nothing but what? The subsets of the bigger set, which is known as the universal set. They have given us one example here. Suppose we want to study the students in class 9th who frequently remain absent. So for this we have to first think of all the students who are there in class 9th in our school. So all the students in our school, or the students of all the divisions of 9th standard in our school, is the universal set. From them we are going to select the students who remain absent frequently. So this number of students who remain absent frequently will be the subset of the total number of students in my school of 9th standard. Understanding? Okay, we move further. Let us see the another example given here. A cricket team of 15 students is to be selected from a school. So for this, first I need to know the number of students who play cricket in the school. So this number of children who play cricket in school will be my universal set. A team of 15 cricket players will be the subset of the universal set. The team which I'll be preparing from the students who play cricket, that will be my subset of the universal set. So it is also shown in the Venn diagram form over here. Now whenever you're writing a universal set, we use a symbol, that is capital U. So always universal set is denoted by capital U. So if you are showing a universal set in a Venn diagram form, you draw the Venn diagram and then you write capital U on top, indicating that this is a universal set. Can you see here, it is shown in the diagram given here. Okay. Now let us learn what is complement of a set. Suppose U is an universal set given to us, and if B is a subset of U, then the set of all elements in U which are not in set B is called the complement of B. I'll repeat. You will just look at the Venn diagram when I'm repeating. If they give you U is the universal set and B is the subset of U, you can see B is drawn inside U. Yes. Now, can you see they have also written B and a dash on top? That indicates B complement. Okay, so this is a complement set of B. So all the elements of universal set. Which are the elements of universal set here? 1, 3, 9, 11, 13, 19, 18, right? But now among these, which are the elements which are not present in B? Yes, there are only 3 elements, that is 1, 18 and 19. Now these elements are nothing but complement of B. Therefore when we solve, we will be first writing. Just look at the steps which are written here. Suppose that the universal set is 1, 3, 9, 11, 13, 18, 19. B is equal to 3, 9, 11, 13. And B dash means the remaining part of universal set which is not in B. That is 1, 18, 19. So here to find B complement, this is how we solve. So B dash bracket dash. So complement of B complement is nothing but universal set itself. Okay. So here using the Venn diagram, you can understand the concept of complement of a given set. Now look at some of the properties which are given here. Before that, can you see that statement which is highlighted above? Remember this? Yes. Complement of a complement is the given set itself. So complement of a complement is nothing but a given set itself. We will try this out when we solve our examples. Now some properties to remember of complement of a set. No elements are common in A and A complement. So you will never have any element repeating in both the set and the complement of the same set. A is a subset of U, and A dash means complement of A will also be a subset of U. Complement of universal set is an empty set. Okay, complement of an empty set is a universal set, so it is reverse. Clear? Now we start with our practice set 1.3. They have given us here set A, B, C, D, and they have asked us to check if the given statements are true or false. First one, C is a subset of B. Now C is equal to B and D. Check if these two elements are present in B. No, one of them is missing, so it's false. Next, A is a subset of D. Are the elements of A present in D? No, so it's false. Third one, D is a subset of B. Check if the elements of D are present in B. No, so it is false. D is a subset of A. Elements of D, that is AE, are present in A? Yes. So this statement is true. Next one. B is a subset of A. Again, just check the elements of B and A. Are all the elements of B present in A? No. So it is false. And the last one. C is a subset of A. Check if all the elements of C are present in A. Yes. So it is true. So this is how we check if the given statements are true or false. Okay. So we look at the elements and we compare and we check. Second question. Take the set of natural numbers from 1 to 20 as universal set and show set X and Y using Venn diagram. First we will write down the universal set. So here the universal set is numbers between 1 to 20. So I'll write down. Okay. Next. They have told us X is equal to X such that X belongs to natural numbers and X is greater than 7 and less than 15. So which are the natural numbers greater than 7 and less than 15? Yes. So that these numbers are 8, 9, 10, 11, 12, 13, 14. So X is equal to these numbers. Whereas Y, they have given for Y such that Y belongs to natural numbers and Y is a prime number from 1 to 20. Now which are the prime numbers from 1 to 20? 2, 3, 5, 7, 11, 13, 17 and 19. Now I have got my answer for X and Y. So I know which elements are present in X and Y. I know the universal set of these two. Okay. Now first I will draw a box which will be representing my universal set. Then I will draw two circles. Okay. Now if you can see here in the diagram given, the two circles are drawn in such a way that they are overlapping onto each other. Now why, I'll tell you. One circle represents X and the other one represents Y. Now check in between the elements of X and Y. There are two elements which are repeating in both. That is 11 and 18. 11 and 13. Now these two elements are going to fall into that section which is overlapping. So that common part between X and Y will be having those elements which are common in both X and Y. Okay. And the remaining X elements will be in the X circle. Remaining Y elements will be in the Y circle. Now apart from these, whatever elements are extra in the universal set. Now which are the elements which are not there in both X and Y? Yes, we have such elements like 1, 4, 6, 15, 16, 18 and 20. Now these will fall outside the two circles. Okay. So this is how you explain the given set with the help of a Venn diagram. Any doubts you can ask me later on, or when the school reopens, I'll be clarifying your doubts. Okay. Let us move further with question 3. They have given us universal set here. They have given us P set over here. They have told us show that the set U, P and complement of P by Venn diagram. So first write what is given, and then to find P complement, we know that universal set minus set P will give me P complement. So my answer is 2, 4, 8, 9, 11, 12. So you only subtract, or you just remove the elements present in P from U, and whatever is remaining, that will be your P complement. Okay. Now same thing I have to show in the Venn diagram form. So first I draw a box which will be my union, which will be my universal set, that is U. Inside I'll draw one circle which will represent my set P. Now which are the elements present in set P? I'll write them inside the circle, that is 1, 3, 10, 7. Now remaining elements which are present in universal set but not in P, I will write them outside the circle. Are you understanding? So the elements, that is 2, 4, 8, 9, 11, 12. These will be outside the circle representing set P, because they are not present in set P but they are complement of set P. They are present in universal set. This is how we draw a Venn diagram to explain the given question. Second part of the question, verify complement of P complement is P. First of all, we know what is P complement. We have done in the earlier part, that is 2, 4, 8, 9, 11, 12. Now complement of this means I'm going to compare this P complement with universal set. Just compare it with the universal set and tell me which are the numbers which are not present in P complement but present in universal set. So these numbers are 1, 3, 7, 10. So this is nothing but our complement of P complement. Okay. Now look at my answer, 1, 3, 7, 10. Isn't it the same elements which are present in set P? Yes, and therefore we prove that complement of P complement is equal to P. Okay. Next question. A is equal to 1, 3, 2, 7. Then write any three subsets of A. Now they have asked us any three subsets of A. Okay, but I have given here all possible subsets to you so that you know how to find a subset. Now subset is nothing but a set which will have its element present in the given set. So I can have either, look at the solution of question 4. I can either have subset as only 1, only 2, only 3, only 7. Then combination of two elements, 1, 2, 2, 3, 1, 3, 3, 7, 1, 7, 2, 7. Or then we combine 3 together. So 1, 2, 3, 2, 3, 7, 1, 2, 7, 1, 3, 7 and 1, 2, 3, 7. And lastly we have a empty set. So basically these sets, if you compare them with our set given in the question, all the elements in them are present in our given set. So they are subsets. So these are the all possible subsets of the given set. But they have asked you only 3. So in exam or in your test, they will ask you particular number of subsets, and those many you have to write down. No need to write everything. Now, if they ask you write all possible subsets, okay, just for your understanding and just to verify if your answer is correct or no, there is a formula which will help you to find out that for a given question how many subsets can be formed. So look at the bottom of the slide. Use the given formula 2 raised to n to know how many subsets can we get, where n is the number of elements in a set. So just use this formula and you will come to know actually how many subsets you can get. So let us verify that with our above answer. Look at the question. A is equal to 1, 3, 2, 7. How many elements are there in set A? 4 elements. So let us apply this in our formula. 2 raised to 4. 2 raised to 4 is what? 2 into 2 into 2 into 2. Yes? So what is my answer? 16. 2 2s are 4, 4 2s are 8, 8 2s are 16. Means I will get total 16 subsets of the given question. Just count how many I have got. Yes, so I have got 16. Yes, so you'll always remember this formula to verify if your answer is correct or no. Whether you have covered all the possible subsets or no. Okay, and you will always remember that every set will have an empty set and the set itself has a subset. You can see the last two subsets which I have written. They will be always present in any question they ask you to write down the subset. We'll start with question 5. Write the subset relation between the sets. They have given us some sets and we have to find the relation between them. Subset relation means who is subset of whom. P is the set of all residents in Pune. M is the set of all the residents in Madhya Pradesh. I is the set of all residents in Indore. D is the set of all residents in India. H is the set of all the residents in Maharashtra. Now, look at the solution. Since Pune is a city in Maharashtra and Maharashtra is a state in India, we can write that P is a subset of H and H is a subset of B. Okay. Similarly, Indore is a city in Madhya Pradesh and Madhya Pradesh is a state in India. Therefore, I can write I is a subset of M and M is a subset of B. Okay. Which set can be the universal set of the above sets? Now, all of these cities and states which they have given, they fall in India. Correct? They are found in India. And therefore, India, which is represented by set B, can be a universal set. Let us start with question 6 and 7. Sixth question, I'll read it for you. Which set of numbers could be the universal set for the sets given below? First one I've solved for you. Second one you're supposed to solve on your own. A is equal to set of multiples of 5. So look at the solution. So set of multiples of 5 means 5, 10, 15 and it goes on. Then B, set of multiples of 7. So 7, 14, 21 and it goes on. And C, set of multiples of 12. So 12, 24, 36 and it goes on. Now, the universal set of set A, B and C can be a set of natural numbers, that is n. Because you can see all the three sets, the numbers which are or the elements which are present in all three sets are nothing but natural numbers. So yes, we can use natural numbers as a universal set for all the three given sets. Similarly, you will solve the second question also in your notebooks. Apply the same logic and write your answer. Question 7. Let all the students of a class in a universal be the universal set. Let set A be the students who secure 50% or more marks in maths. Then write the complement of set A. Now we have here universal set is set of all students of the class. A is set of students who secure 50% or more marks in maths. So complement of set A will be U minus A, which is nothing but set of students who secure less than 50% marks in maths. Okay, so if you're subtracting U minus A, means you're getting the remaining number of students who are securing less than 50% marks. Easy? So you just write your answer in statements like this. Here we do not write any elements or anything like that. You're only going to state your answer in statement.